Hello, everyone. We are here with our next talk, and I would like you to welcome Abdel, a good friend that I now know for quite some time. He is also the co-host of the Kubernetes podcast by Google, and he will talk about modern development of cloud applications with Service Weaver. Enjoy and have fun. Thanks for being here.
Thank you. I'll try. Thank you, everyone. Can I get my slide? Yeah, thank you. All right, cool. Before I get started, how many people here are Go developers or write code in Go? Oh, beautiful. Okay, cool. That's pretty cool. Okay, so hopefully you enjoyed this. That's because Service Weaver is a Go framework, right? So if you've never really, even if you're not a Go developer and you don't write code in Go, if you're familiar with, there is a framework that Microsoft released a few years ago called Dapper, D-A-P-R. I think some of you heard of it, maybe one person. Okay, it's kind of the same concept. Anyway, so my name is Abdel. I'm a developer advocate based in Stockholm, Sweden. I basically work mostly on containers and Kubernetes stuff. That's why I host the Kubernetes podcast, and I also do Go. Right? I'm an old school developer. I came from the Java and Bash world, arguably one of the best programming languages in the world, Bash. And then I kind of like graduated toward Go, and I'm in the process of learning Rust. And I got interested in this project when we open sourced it last year or 2 years ago, because it's actually pretty cool. So I'll show you something. So okay, microservices are popular. You know, there is a lot of things that people use for doing microservices. I'm not gonna bore you with these details. The main problem that are associated with microservices is that there is no one knows how to do them, right? Like no one really there is no such a thing as a guide for the perfect way of doing microservices. It's actually so bad that the community, or us, the tech people, invented a new word, which I just discovered this week. And I'm going to share it with you. I don't know if you know it. Macroservices. Have anybody heard of macroservices? No? Okay. So apparently there is monolith, right? And there are microservices. And then I don't know who this person is, invented a word called macroservices. And macroservices are essentially, it's supposed to be the best of both worlds. It's the services that are the right size, whatever the right size is, right? Because that's one of the biggest problems with microservices. Like, what's the right size of a microservice? Is it supposed to be big or small or XL or XXL or M or whatever? Most people think that microservices are like the way to go. Like so these are all comments, by the way, we collected from the Y Combinator Reddit kind of thing. A lot of people think that they're doing microservices the wrong way, in the sense that they don't know how to draw the boundaries, like where exactly does one service stops and another service starts, right? Most people think that microservices are essentially just anti-monoliths, right? That's kind of seems to be the case. And most people think that microservices are okay, but the problem is people. The problem is that the people that implement microservices don't know what they're doing, and they are the one that cause all the problems, right? And then it seems like a lot of people actually don't know if they are doing microservices or monolith applications or a combination of both, right? These are just comments we like collected. So one of the biggest problems with microservices is that there is this, like, I call this the FANG effect. FANG starts for like Facebook, Apple, Google, like all the big companies, right? And the FANG effect essentially is when any of these big companies publish an article where they say, we went from this architecture to this architecture and it helped us solve 99% of our problems, the entire tech industry just follows them, right? Because everybody thinks that they are Google. Everybody thinks that they are writing a service that is used by 1 billion users. And everybody thinks that whatever Google publishes is the right way to go. And that's actually that's actually really bad. That's like the wrong type of influence. We don't want people to be doing that. We want people to be able to do the thing that makes sense for their application. And just to illustrate my points, have anybody seen this article a few months ago, from AWS, the AWS Prime, the video streaming service? One person? Okay, 2 people. Okay, so let me give you the TLDR. So inside AWS Prime, which is the video streaming service, right? Some team does they are responsible for video quality, right? So what they're supposed to do is that they're supposed to catch the stream of the videos and analyze them to verify if they are streaming good quality videos, right? And so they obviously use AWS, right? So what they did is they wrote a service that that does like quality analysis on the videos. And the way they wrote it is that they used AWS Lambda. And so they wrote one function that captures the stream and then split it into individual frames, right? So if they are framing or if they're streaming a 4K video at 30 frames per second, so that's 1 frame per second. So 30 pictures per second of video, right? So again, let's reiterate. You know how AWS Lambda works, right? It's a function, and then each time you trigger a function, you pay for it. So for every single video, they were triggering the function 30 times per second for every video, right? So they wrote 2 functions. It's like one function that basically captures the videos, splits it into the individual frames, and another function that does the actual quality analysis, right? And so they wrote this application this way, and then they realized, well, it doesn't scale, it costs too much, all that stuff. So they just fall back into using ECS, Elastic Container Services, the container tool from AWS, right? Which essentially is a monolith application. So they took these 2 functions, they just smooched them together, wrote one single application that does both the frame splitting and the analysis. And then they wrote this article, which says, by moving from microservices to monolith, we saved 90% of the cost. And a lot of people were like, yes, of course. Like, what the fuck, you know? Like, of course, from moving from individually triggered functions to a single application with a single process, you're gonna save costs, right? So this is just to illustrate the point of why microservices are very hard. Because when you start doing things, especially if you're writing a new application, if you really don't know what you are doing, you might do what AWS did, right? Or what these people at AWS did. You might go with one architecture and then you realize later it doesn't work, and then you switch back to monoliths, and then you save on costs, and you're like, oh, monoliths is better than microservices. So the reason why this is a problem is because there is basically no official guidance for how to do microservices. Like there is nothing, there's like no such a thing. Like there are articles, and I hate to break this to you, like 99% of tech publications are opinions. Like people just publish their opinions. That like no one knows what the fuck they're doing. Like people publish the stuff that they think are the right way to do things. And actually it's even worse than that, because I started blogging a few years ago and I was using Medium, and I realized that like on Medium there are actually people that publishes articles that are how does Uber connect drivers to users. And these people don't work for Uber. They just like speculate how Uber works. And it's just like, it's so bad, it's really bad. So there is no official guideline. That's the problem. Microservices are not neither good, neither bad. It's about a trade-off, right? What do you want to trade off? Do you trade off the ease of deployment versus the ease of maintenance? Do you trade off the ease of scaling versus the ease of not scaling? Does your application actually need scaling? If your application is used by 2 users, you probably don't care. And on top of all of this, the fact that we are in the cloud environment or in the cloud first world, essentially, it makes things even worse, because things are complicated. Cloud is complicated. People have to learn a lot of things. Is anybody here a full stack developer? Well, I hate to break it to you, you are not. And there is no such thing as full stack developers. People don't, like, you either know front end, you know back end, or you know databases. You cannot know all of them, right? Let's just make it this way. I'm not shitting on you. The point I'm trying to make here is that, like, you cannot be good at everything. You have to be good at one thing, and you have to be okay at other stuff, right? Or you can just be like me, and usually what I tell my manager is that I am mediocre at everything. So I try to be okay at some stuff. So what we did is we basically looked at all these problems, and we came up with an idea of how can we make microservices development easy for people. And so the way we could do it, or one way we could do it, is if we could write a modular binary. A modular binary, essentially, it's a single binary, but in it, we can split code in a logical way into modules. And then those modules can be together as a monolith application, or they can be split into microservices later. The idea of Service Weaver is to delay this decision of doing microservices and monoliths as far as possible. If you are starting to write your code today, you don't have to worry too much today about whether you want to do microservices or monoliths. You can delay that decision later. So how does it work? So Service Weaver basically works on 4 different fronts. Development, so how do you organize your code? How do you connect the modules together? How do you deploy the application itself? You can deploy it as a single binary, you can deploy it as multiple binaries, or you can deploy it as containers into Kubernetes. Performance, I'm going to show you a little bit some benchmarks later. And then we built into it metrics, login, tracing, etc., etc. So for development, we basically use in a Go, we use the concept of interfaces. So each interface is a component, and each component is basically implemented as an interface, right? So here, this is an example where I have 3 components: rock, paper, scissors, and then I can either run them locally as together as one process, or I can just decide to run them as multiple processes. I'm going to show you an example later. So how do we define a component? A component is just an interface. So we define a type interface. Inside that interface, we have a function, which is the actual function of the interface itself. Then to implement the interface, or to implement the component, we use this function called weaver.implements, and then we call the function. And then if we want to instantiate or use the interface somewhere else, we just need to use the weaver.ref. So weaver.ref is the instantiation, and then weaver.implements is the actual implementation. When we pass an interface to Weaver through the implements function, that basically tells the service Weaver that you should weavify, we call it. Weavify essentially means this component is now part of Service Weaver framework, so the framework is aware of it. So that later on, if we need to split this up, to give you a very concrete example, if we want to take this cache component and run it as its own individual microservice, then Weaver will implement the underlying gRPC code for it. So it will generate all the gRPC, all the protos, all that stuff. So you don't have to worry too much about it. So, and then yeah, then you basically call the Weaver. So in wherever you need to use the application, you just need to call the weaver.run function to be able to call the objects or the interface. So let me show you an example, a very, very stupid example here. Let's see, I have it here. I think I have, yes, hello world, cd examples. And then I think I have an example inside the whole hello world. Give me 1 second. Yeah. Or maybe it's not hello. Let's try this one. So okay, so inside this component called hello world, I have an interface here. It's called reverser. It's implemented as an interface. It has a function called reverse, and then to implement it, I just use the weaver.implements. And then if I want to call it, I literally have to just call. I need to be able to call the interface through the ref command. So through the ref, I can instantiate or import if you want. And then what I have to do is I just call the app.reverser.get, and .get will call the function for me. .reverse, that's the actual function inside the interface. Sorry, app.reverser.get will get the interface, and then reverse is the actual function. If I go back here, inside the reverser function, I have an inside the reverser interface, I have a function called reverse, and this is how I call it. So reference it and then call it this way. So let's go here, do this. So basically I just need to do a go/run, and I think hold on a second, I haven't tried this for a while. Let's see. Yeah, that should be, and then I should be able to just do a curl on this here. What? Okay, that doesn't work. Why? Okay. Different port. 41399. 41393. What? Okay, didn't work for some reason. Okay, I don't know why. Maybe I can call it this way. Let's see. No. Slash. Come on. Slash hello. Yeah. Okay. So yeah, you can probably see it here. It's very small. Sorry about that. Yeah. So the function has an endpoint called hello, and because in the application itself, what I did is I try to get whatever message is passed, and if it's not passed, I just default to hello to world, and it's just reverse world for me, right? So to recap, reverser is a component. It's an interface. Main is the actual main application. Through main, I called Weaver through the reference function, and then I do the app.reverser.get to get the interface, and then .reverse is what gets me the actual function that I need, right? So pretty straightforward, right? I can show you another example actually. Give me a second. Let's see. Close all of this, and let's see. I think I have a thing here called examples chat. Let's see if chat works. I think chat should work, right? Or no, is it chat that I want to show? Or hello world? Let's see. Yeah, okay. I'm gonna, okay. So if you want to, so if without doing anything, like without, you don't have to have this weaver.toml file. This is just a configuration file that allows you to configure extra parameters of Weaver itself. The most basic example is this one that I showed earlier, where I just have, okay, I have a service Weaver, and basically I say I have single binary, and the binary is just called hello world. So this is like the most basic example. I'll show what that TOML file means. So releasing, I can release my function as a single binary. This is essentially what I just showed, single application, single binary. Or I can deploy it into multiple binaries or multiple components or multiple applications. So in order to do the multiple deployments, I need the TOML file. And in the TOML file, I can specify if I want to deploy locally, if I want to do a deployment to multiple machines. You can actually put your public SSH keys into the file and then decide if you want to deploy the application or the components to multiple virtual machines or physical servers. Or I can deploy to Kubernetes, right? And it will generate all the Kubernetes code for me. So this is an example. The first example is a single binary. The second example is SSH. And the third example is using Kubernetes. This is a particular example which uses GKE, which is our version of Kubernetes, Google Kubernetes Engine, but it just works with like regular Kubernetes. And then to deploy, it's essentially as simple as Weaver multi-deploy. So go/run will run a single process. Weaver multi-deploy will run a multi-process, SSH or GKE or Kubernetes. And so that's the example I wanted to show next. So I showed the hello world example, so I'm going to show this one actually, which is the one inside the hello example. Yes, so this is an example where if I just do a go/run, like I did earlier, it will just release a single binary called hello. But one problem here you might notice is that it defaults to like a random port. If you don't want to do that, you can do Weaver single deploy, and then I need a config file. How do I specify the config file? Weaver.toml. So if I run weaver.single deploy and then I specify the file, then it will read from the file, and in this case it will start on 1, 2, 3, 4, 5, right? So if I go back here to this endpoint somewhere, 1, 2, 3, 4, 5. Yeah, then it just works, right? Very simple. Now this is not as impressive as an example, but let's see. Actually, one thing I forgot to show, is that Weaver itself, the command line, has a built-in status So if you are debugging your application, you can do Weaver single status, and it will tell me, okay, I have one deployment, I have one application. The application has two components. There is the Weaver component, the reversal component, and then the Weaver main component. And then it's listening on one port 1, 2, 3, 4, 5. That's because Service Weaver actually was designed for backend applications, and so for backend applications you need a port. I can also do something. So if I stop this and I just replace this single with multi, what it will do essentially is, you remember in my example here, I have two components. I have the main component and the reversal component. It will basically take those two components and run them as two separate processes. It should no, okay. So of course, then I have to do multi status, and then okay. So now I have two different processes, and you can see that each process has its own PID. So now I have my main function and my reversal function running as two different processes on my laptop, and they are like talking to each other through gRPC. Again, I don't need to show the example. I don't need to show it's working, but you get the point. And then if I want to deploy to Kubernetes, then I need to just do the same thing with the Weaver function and just do Kubernetes, for example. And I'm quite sure that this will not work. Because cube, sorry. Deploy weaver.toml. Okay, this is not gonna work for this example. I do have another example here which has the cube deployment, I think, hopefully somewhere. Let's see. Not the chat function. Which one? Oh, damn, I forgot. Not the hello world, not the reverser one. Let's see. The reverser one has the cube one. No, it doesn't. Okay, doesn't. Basically, the point I'm trying to make is we have a subfunction called cube, and you can just run the cube command with the Weaver command line, and it will either deploy or generate just the Kubernetes files for you. So if you don't want to worry too much about YAML and writing Kubernetes files, it will generate those for you. So that's for deployments. Again, TLDR, you create an interface, you implement the interface through the implement command, you reference it through the ref command, and then you call it through the get command. As simple as that, right? Deployments, you can deploy as a single, you can deploy as multiple, you can deploy as a Kubernetes or to GKE directly. If you are deploying to Kubernetes, you can actually specify directly some very specific Kubernetes stuff. So if you are familiar with the concept of Kubernetes for requests and limits, when you're deploying an application to Kubernetes, you can decide how much requests you want, how much resources you want to assign to your application in terms of CPU and memory. So then you can specify that directly into the cube.yaml file. So new file, and then you deploy, you specify how you want your application to be deployed. If there is anything that Kubernetes requires, you can specify directly inside the cube file. And then it comes with built-in telemetry. So it has built-in Prometheus, built-in Jaeger, and through Prometheus, you can just plug in Grafana and get telemetry out of the box. And then it also has like built-in support for like CI/CD systems like Argo and Jenkins and all this stuff. So we talked about the deployments. How do you run the... so under the hood, what Weaver really does is it implements its own libraries, and these libraries will implement all the communication between the processes you need. So if you need to do multi-process or multi-applications, again, aka microservices, then under the hood, Weaver will generate all the gRPC stubs, all the files for you, and then it will also do all the service discovery. So that's the parts I wanted to show. And you will have to bear with me because I don't remember where the example is that I wanted to show. So give me a second. I'm going to have to figure it out. Weaver. That's not what I want. This is blah, blah, multi. Do I have the cube one here? I think I do. Yes, I think I do in this example. The problem is I don't remember where is the cube file itself. But let's see. How to run on Kubernetes. blah blah shell kubectl MySQL. Good. Blah blah blah. And then update the repo field in yeah, here I have it here. Sorry about that. Yeah, okay. So this is an example of how do we do it in Kubernetes, right? So if I go inside this folder, okay, so let me show you what this example does. So I'm gonna open the main function here, which is I think the server.go. Yes, so I have my main function inside the server.go file. So basically this is implementing the main function, and then inside of it I have 4 different components. I have a component called store, scalar, cache, and chat, and each of those are its own file, right? So each of them is an interface, which is implemented through the interface type in Go, and then inside of it I have so this is the interface itself called SQL store, and then you have the functions, whatever that interface needs to do, and then the server.go is the file that just group all these things together. So I just call the SQL store, the image scalar, and the local cache through the ref command. I implement the main function through the weaver.implements command. And then I have my weaver.toml here, which specify if I want to run it as a single binary, it will compile all of this is single binary called chat. But if I want to run it as multiple binaries, it will listen on port 9000. It doesn't matter. But what's important here is this file here called kubedeploy. So in the kubedeploy file, I specify the Weaver file I need. I specify the repository. So that's essentially where do you want to push the images, because it will also build the images for you, by the way. Thank you. And then it specify what is the actual listener. So which component of all these components is going to be the public one. So if I go here and I do weaver kube deploy weaver.toml or kube deploy.toml. Okay, here we go. So what it will do essentially is that it will look at the configuration file and then read the code, and then it will build an image for every single component. So because I have 4 different components, the server is one of them, and then I have 3 more components, each of them will result into building an image. And this is gonna fail, I think, because I need to authenticate, but it doesn't matter. But essentially what it will do is that it will build a component or a container for every single component, and then push those to my container registry and generate all the YAML files for my Kubernetes deployment. I think I will want to show it anyway, because gcloud auth login. Sorry, should have done this before. Just pretend you're not looking at what I'm doing right now, because I'm not supposed to show you this. Well, I mean, it's okay. I'm not going to show you my password, but there will be one piece of code you're not supposed to look at, which I think is going to be fine if I still show it. Where is my code? Here. There we go. All right, my password is there. I go there. I put my password without showing it. Good. We're still good. Authenticate with my second factor authentication. Next. This is the part you're not supposed to see. Come on. Do something. Yeah, okay, cool. Continue. Allow. This is the part you're not supposed to see. Okay. Let's pretend you didn't see it. Okay, good. So, I'll do this again. And meanwhile, I'll just go here and I'll just refresh my Go Cloud Console, and I'll show you artifact registry. Switch the projects. 1 second. Boom. And then that should basically drop me into our, so this is just our Google Cloud built-in artifact registry. You can use whatever artifact registry you want. I think in my case I pushed them into Europe North 1, so they should be there. So if we go into containers, I should be able to see that I have my chat application, which is a single container, but I can also build this as multiple containers, right? So if I delete this one more time and just do that, then it should just build the container and then push it into my container registry. I don't need to show you more details. I think it's I think the idea is pretty clear, right? Like just generate YAML files, generate the components. And then if I look into this file here, this is the most important one. This is essentially my YAML file. So it generated also the YAML file for me for the Kubernetes deployment, right? Again, I didn't write any Docker files, right? I didn't write any YAML files. I didn't do all of that BS. I just wrote code, ran Weaver, generated all the images for me, and that did all the magic behind the scene for me. So I don't have to worry too much about it. So yeah, that's it. That's basically the TLDR of what Service Weaver does. Let me go back to my slides. I just still want to finish a few things, and I will leave some time for questions at the end. Yes, so we did some benchmarking. What we did actually is we took this application called Online Boutique. It's an app that I mean, people in my team wrote, and it's a microservices app that we initially wrote to demonstrate Istio service mesh, but then we basically use it for all sorts of things. It's written in multiple programming languages. Some of them are Go, some of them are other stuff. So what we did is we took it and we rewrote the whole application in Go using Service Weaver, and this is what the results of the benchmark was. So from just a pure lines of code perspective, with the Service Weaver, we have way less code. We literally have 0 config code, and then we have about 1,000 lines of code less than the actual old application. And then on the so the reason why there is less code is because there is no service discovery. So the application itself, because of the Service Weaver, the service discovery is built in. So all the code which is service discovery and trying to figure out where the other microservices are is gone. And then on the performance, you can see that it's actually performing way better than how it used to be. Yeah, you have some built-in telemetry. So I told you about this. Yeah, you have a logger, of course, that's the default logger in Go. You have a built-in open telemetry. You can just basically call the open telemetry agent or the open telemetry library, and then we will expose those for you. I did already a demo. So yeah, so essentially the TLDR is Service Weaver will allow you to write applications as modular binaries. Each binary is an interface, or each component is an interface. Implement them, do all the service discovery, deploy them as single binary, deploy them as multiple binary, yeah, then you don't have to do service discovery. You don't have to write code for containers, for YAMLs, for Kubernetes, for all that stuff. This is what we're working on. We are working on multi-language support. We want to extend Service Weaver beyond Go. And the language we're looking at right now is Rust. That's because I like Rust, and because why not, right? Doing some better performance improvements. We're like working on some extra, just like tweaking for the underlying performance itself. And of course, because everybody is doing GenAI, we're doing also some GenAI stuff. And yeah, that's it. That's all I have. I hope this was useful. I know I've been all over the place. If you have any feedback, scan this QR code and send it to us. And that's the email, and that's the website, serviceweaver.dev. If you want to try it out. And yeah, that's it. Thank you very much. I hope this was useful.
Thank you.
How much time do I have? 5 minutes? Yeah, okay.
We currently don't have any questions. Any questions from the audience?
Either this was useful or no one understood what the fuck I was talking about for the last 35 minutes. So, did anybody learn anything new today from this? Ah, oh, cool. Most of you. Good. Okay.
Yeah. Thanks, Abdel.
No worries. Thank you very much.
Thanks for the demos. And we are looking forward to dig into this.
Thank you. Thank you very much.